All right, Algebra 1B students, welcome to part 1 of lesson 8.6. Today we're going to be talking more about factoring or learning a new skill in order to do some more complicated factoring, where we're going to have a number in front of our x squared in a quadratic. That is where we're heading, but for today we're just going to talk about a new skill that we will use tomorrow in order to do that. One more problem, just so we can remind ourselves about factors. We're going to list out all the factors of 12, meaning numbers that can multiply to get to 12. And I will always, when I'm trying to list out factors, start with the number 1, and then go way to the other end and list out the number that goes with 1, that is 12, because I know 1 times 12 will give me 12. Next, I check and see if 2 will work. I believe it will if I do 2 times 6. And finally, I will do 3 times 4. So there are my factors of 12. And if I want to check my work and make sure I didn't miss anything, I can connect 1 to 12, 2 to 6, and 3 to 4. Everything should connect to some other number, and there shouldn't be any left over. There's the factors of 12. In what we're going to be doing today, which you can see a little preview of down here, diamond problems, you will need to make sure you know the factors of different numbers and what those factors add up to. Now, let's talk about this crazy new concept called a diamond problem. Okay? Last week, we were working on factoring a quadratic equation. We were looking for 2 numbers that multiplied to be some number and added up to be some other number. Yes? Hopefully you remember that from what we were working on last week. Tomorrow, we're going to look at much more complex quadratics that we can also factor. Okay? Today, we will look at a new tool to help us find the factors that we need. A new tool called a diamond problem, or a diamond method for solving these types of problems. The first thing I do is create a large X. This is where the diamond problem comes from, because if I connect my 4 numbers, which will eventually be in there, they would be in a diamond shape. Okay? Now, I put the product of the 2 numbers that I'm trying to find on the top of the X, and I put the sum of them on the bottom. So essentially what I have here is I want them to multiply to get me 10, and I want them to add to get me 7. I want them to multiply to get me 10, I want them to add to get me 7. So I think, what 2 numbers can I multiply together to get 10? Those, again, like our warm-up, are factors of 10. I could do 1 and 10. The question is, do those add up to be 7? The answer is no, so I don't think it's 1 and 10. I could also do 2 and multiply that by 5. Do those add up to 7? Yes, they do. So I finished my diamond problem, and here's where the term diamond comes from. Those 4 numbers make a diamond right there. So my diamond problem is just a way to organize, to graphically organize my finding 2 numbers that multiply to this and add to this. 2 and 5 times to get 10, add to get 7. Right? And that's step 3. Except I have them in the other order. Finally, I put the 2 factors that I want on the left and right sides. 5 and 2. Okay. That is a diamond problem. Just a new way to organize, really, what we've already been doing in our factoring. Okay. The next question, obviously, is what does this look like algebraically? What does this look like with variables? Okay. Now, again, in the diamond problem, which you can see I have set up here, I want the 2 numbers that are going to go here and here to multiply to be the top number. Multiply to be the top number, and add to be the bottom number. So I want them to multiply to be 6x squared and add up to be 5x. Now, the first thing I want to point out to you is the x squared. When I see an x squared, that means I need an x here and I need an x here because they're going to multiply together to get me that x squared. Okay, so I know I need an x and an x. The question is, what two numbers should I put in front of them to get 6, but add up to be 5x's? Well, I could try a 1x and 6x, but I think those will add to be 7, so that's no good. That's not what I want. I could try 2 and 3x. That's it. Because 2x and 3x multiply to get 6x squared, and they add together to get 5x. So now I have my two factors here, 2x and 3x. One more question for us for tonight. How are we going to use these to factor these quadratics? And the first thing that we need to do is look at what is called a generic rectangle problem. Okay? Generic rectangle. This is another way to organize our foiling method. Okay? This is to organize FOIL. That is what the generic rectangle problem does. Okay. So as we can see right over here, I have a FOIL problem there for us. 3x plus 3 times 5x minus 2. I'm going to turn to this generic rectangle here to help me do this. Okay? To set up the generic rectangle, I make a window. Okay? I make a box, and I put these crossing lines in it. On the edge, I put my two factors of that I'm trying to FOIL or trying to multiply together. Okay? So 3x plus 3, I put the 3x here, and I put the 3 here. And you can think of a plus sign being in between. 3x plus 3. And then I have 5x and a minus 2, which you can think of as a 5x here, and then plus a little negative 2 there. Okay, so I have 3x here, plus 3, and I have 5x plus a negative 2, or 5x minus 2 from right there. Okay, so I've set up my window, I split, I put my factors along the left side and the top side. Yeah, first factor goes on the left side, then it goes along the top side. Okay. Now, in order to FOIL this, what I would do is do 3x times 5x. But 3x times 5x is really the two sides of this box, essentially the length and width, isn't it? So I'm going to multiply the 3x times 5x and put the answer right here in this box. 3x times 5x I know is 15x squared. That is the first pieces of each of my factors. Okay. The outside piece, in this case, is 3x times negative 2. 3x times negative 2, that's the length and width of this box here. So I will put the answer to that multiplication in that top right box. 3x times negative 2. 3 times negative 2 is negative 6, and I have an x attached, negative 6x. Then I'm going to do the inside, which I know is 3 times 5x, 3, which is here, times 5x, which is there. Now I'm down here in the bottom left box. 3 times 5x is 15x. And finally, I have 3 times negative 2 as my last from over here, which I will do last over here and put in the final box, negative 6. So now I have my 4 pieces, and I can simply put together the like terms and find my answer. So I have 15x squareds. I have a negative 6x here, and I have a positive 15x here. If I put those together, that's a plus 9x minus 6. All right, that is my answer there. Now, something I would like you to notice that I need to point out here. This is something to add to your notes, please. Put this in your notes. The top left and bottom right squares, this and that, multiply to be the same thing as the bottom left and top right squares. And let's just check that real quick. I have negative 15x squared times by, I have positive 15x squared times by a negative 6. That is equal to, well, negative 6 times 15, I know is 90, and x squared will just stay there. So this is negative 90x squared. Now if I look at bottom left and top right, that's 15x times negative 6x, and that is equal to 15 times negative 6, again, is negative 90. And I have an x here and an x here. Those add, or multiply, to be x squared. So I have negative 90x squared there. I have negative 90x squared there. Okay. I will show you one more example, and then we'll be done. And tomorrow we will look at factoring using these diamonds and rectangles. Okay. So one more example of one of these generic rectangle problems. I will do, in this case, 5x plus 3 times by 7x minus 1. Okay. Step 1, I will make my window and make my crossing right there. Now, across the left side, I'm going to put my first factor, which is a 5x and a positive 3, with a plus in between. And then along the top, I'll put my other factor, which is a 7x and a minus 1. Okay. So my first in the FOIL method is going to be my top left square here. 7x times 5x is 35x squared. My outside, 5x and negative 1. 5 times negative 1 is negative 5x. Inside here will be 3 and 7x. 3 times 7 is 21 with an x. And last but not least, 3 times negative 1 is negative 3. Okay. Now, if I put together my like terms from these two right here, I will have my completed FOILed out product, which will be 35x squared minus 5x plus 21x, I believe, is a plus 16x, and a minus 3 at the end. Okay. Now let's check again our thing to notice. And as I mentioned before, bottom left, top right, that multiplication there should be equal to that multiplication there in these generic rectangles every single time. Okay? So 35x squared times by negative 3. 35 times negative 3. If you check that on the calculator with me, you will get negative 105, and I still have my x squared attached. I'm going to give myself a little more space here. And then do my other multiplication, which is 21x times by negative 5x And if I do that multiplication, check that on the calculator with me, it's negative 105. And I have an x in each piece, which gives me x squared. X in each piece gives me x squared. So, in a generic rectangle, when we use that to multiply out or FOIL out a product, the top left and bottom right squares multiplied together is always equal to the bottom left and top right. That will be very, very important tomorrow. Your classwork tomorrow is mostly about these diamond problems, but I may ask you to do some generic rectangle foiling as well. If you have any questions about what I just did, please make a note to ask me in class tomorrow. Otherwise, that's all I have for you right now. Have a wonderful night.